Alrighty, back with part 3, last part. And actually this shouldn't take as long because we really only have 2 questions on the front and then the constructed response on the back. So we'll finish this up, and then hopefully this video won't be nearly as long as the other 2. So yeah. All right, let's look at this. So number 22, graph the line described by this equation. So we could put it in slope-intercept form, find the y-intercept, blah, 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 but we actually already know a lot about the graph from this point, from this line, or from this equation. We know the slope. The slope is -1/4. We also know that it goes through a particular point. The x-coordinate of that point is 2. The y-coordinate of that point is -8. Remember, the point is always the opposite sign of what it is in the equation, in point-slope form. If it's truly in true point-slope form, then it will be the opposite sign. All right, so I know it goes to the point 2, -8. So I'm going to go over 2, down 8. So it goes through this point, and it has a slope of -1/4, which means I would go down 1 and over 1, 2, 3, 4. Down 1 and over 4. Up 1 and left 1, 2, 3, 4. Up 1, left 1, 2, 3, 4. Up 1 and left 1, 2, 3, 4. Okay, and then we are going to connect those dots. Okay, so just to kind of double check, let's just say that was not your forte, like point slope, and you and point slope don't agree. Why don't we put this in slope intercept form and see what it would look like? So if I were to put it in slope intercept form, remember slope intercept has y by itself. It also doesn't have the parentheses. So what I would do first is maybe distribute this 1/4, or -1/4, excuse me. And we would have y plus 8 equals -1/4 of x plus, because negative is positive, 2 times 1/4 is going to be 2 over 4, which reduces to 1/2. All right, then to get y by itself, we would subtract 8 and subtract 8. And so when we do that, these cancel and we get y equals -1/4. And then when we, 1/4 x, and then when we subtract this, remember to subtract, they have to have a common denominator. So -8 over 1, I would have to add it to this with this 2. So I'm going to have to multiply the top and bottom by 2 to get a common denominator. That's going to be -16/2 plus this positive 1/2, which would give me a -15/2. Okay, so we've got it in slope-intercept form. All right, so let's think about this real quick. 16/2 is -7.5, which is about where it, okay, I didn't graph straight, but if I had a straight edge. See, like I told you in part 1, that's why you always have your ID on you. If I graphed it a little more straight, it would have been at -7.5, which works, but it kind of was easier to use that, wasn't it? So this is an option, but that was kind of easier. So, yeah, so why don't we just ignore all the stuff in gray and just try it in the brown that time. Okay. All right, 23. I love this problem. Dr. Sassafras reads the back of a medicine bottle and sees the following data. Create a scatter plot based on the data. Okay, so let's look. First thing I need to do is decide what's going to be my x and what's going to be my y. So I usually typically do the top as x and the bottom as y. So my weight will be x, my dosage will be y. So let's see. Our scale from this goes from 90 to 200, and it is a scatter plot, so it doesn't necessarily have to start at 0. I'm still going to put a 0 here, but I'm going to put a break. And then, let's see. We go from 90 to 200. How many blocks do we have? We have 90, 100, 110, 120, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. 90, 100, 110, 120, 130, 140, 150, 160, 170, 180. So why don't, I'm going to start at 80 and go up by 20. So 80, 100, 120, 140, 160, 180. Oof, this is ugly. We're going to do 80, 100, 120, 140, 160, 180, 200, 220, 240. Okay, that looks a little bit better. And this is our weight. Okay, this goes from 20 to 75. So let's go up by tens, I think, is what might be the best. So 10, 20, 30, 40, 50, 60, 70. Actually, I'm going to go ahead and put 20, 30, 40. And didn't look right. 60, 70, 80, 90. Sorry, sometimes my graph doesn't look right. And that is the dosage. And weight is in pounds. And dosage is in milligrams. Whew, my scale looks terrible. Like, that is some ugly handwriting. I've never had handwriting quite that ugly. Like, I'm halfway tempted to go get another copy, but, like, I don't want to do that to y'all. We're already 7 minutes in. Alright, so a scatter plot, basically we're just graphing the data. So when X is 90, my Y is 20. So at 90, 20. At 100, it's at 25. At 110, it's at 30. At 125, it's at 35. At 140, it's at 40. At 155, it's at 53. At 170, it's at 60. At 180, it's at 66. And at 200, it's at 75. Okay, so that is my scatter plot. Now, is it a perfectly straight line? No, and that's okay. It doesn't have to be. Honestly, it probably shouldn't be. Scatter plot is real data, so does it have a linear trend? Yes, it looks like fairly linear, but it's not a perfect linear line. We could probably use a line to model our data, but it's not perfectly linear, and that's how it should be, because real data very rarely works out perfectly. All right, so let's flip over to the back, and we get to our constructed response question. So the constructed response is worth a good bit of points, so I want to see good, thoughtful answers and good, thoughtful points. All right, so let's read the problem first. Wendy's window washers, charges an Affordable Care Act tax of $50 in addition to $25 per window washed. So write a function that describes the cost to hire Wendy's window washers to wash windows. Whew, say that 5 times fast. All right, so function has to be in function notation, so we'll do f of x equals. All right, how much is she charging per window? $25. So this function is telling me the cost, because the cost is dependent on the number of windows. So X is my number of windows. f of x is my total cost. Okay, so f of x is my total cost, x is my number of windows. So how much am I charging per window? I'm charging 25 per window, so 25 is my slope, 25 times x is 25 per windows washed, so that needs to be with my number of windows. And then we have a $50 tax that it doesn't matter if you have 1 window washed or 500 windows washed. We're charging $50 to take care of that tax. All right. So that's my function. That's all you need. Easy peasy. All right, B, graph the function to represent the total cost. All right, so, and it says label several points on the graph. So, we need to have good axes. I think y'all have figured out by now that if your axes aren't correct, then your graph's not correct. I know it feels like we're Nazis over it, but if it's not scaled right, a linear function will not be linear. And vice versa, a function that's not linear could look linear. And we need to know the shapes of those graphs. They're important. It's not just for my amusement. It's important to know that, hey, this kind of graph has a J shape, or this kind of graph is linear, or this kind of graph is a parabola. It's one of the most important things. So you have to have this scaled correctly. So we're going to start with 0, 0. And so we'll just have a couple of points on the graph. So the number of windows is my x. So number of windows. So we need to make sure we have that labeled so I know what I'm graphing. So this is my number of windows. And then we're going to, sorry, I'm getting text from my family. We're going to start scaling this. So we'll just go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So going by ones is pretty reasonable here. All right, and let's talk about my money. I'm charging $25 per window. So 25 sounds pretty reasonable. So 25, 50, 75, 100, so on and so forth. Keep on going until you run out of room. Hope I'm not getting annoying. All right, so there's our number of windows. This is our total cost. So windows and total cost. So first thing I'm going to graph is how much it costs if I have no windows washed, which I know logic would say, well, if I'm not washing any windows, I'm not paying for anything. But if you hired the company to wash windows, before you start washing windows, it's going to cost $50 in tax. Okay, so if I have a second window, or one window wash, it's going to cost me $25 more. So that would be cost a total of $75. So my slope, remember my slope is 25. So you're not counting 25 boxes and going over. Since my slope is 25 and each box is worth 25, I can go up one and over one. So here's my question. Do I connect the dots? Well, think about it. When you wash windows, are you going to like wash a half a window or 2.5 windows? No, like you're gonna wash one window or 2 windows. You're not washing in between. So I would keep this discrete. So this should be discrete. And I've had a lot of people ask, well, how can you tell? You have to actually read the scenario and think, does it make sense to have an x value between 1 and 2? Or does it make sense for me to have everything between 3 and 4 in my problem? Here it doesn't make sense. Right here, the only thing that makes sense is washing 1 window or 2 windows. So this should be discrete because I wouldn't wash 1.3 windows. and I'm not going to prorate my pay for that. I'm going to pay you $25 for one or $50 for two. I'm not going to pay you $27.56 for however many, one in however many windows you wash. It doesn't make sense. Okay. So C, identify the y-intercept and tell me what it represents. So my y-intercept is this point right here. My y-intercept is 0, 50. If you do not put it as a coordinate, I'm not giving you points. 50 is not the y-intercept. The y-intercept is 0, 50. It is a point. It is a coordinate. What does it represent? That is the Affordable Care Act tax. That's charged prior to washing the windows. So, and one of the good things to bring up, the reason why it's 0.50, so this is before washing the windows, that care tax is not affected by the number of windows washed. So that's why it doesn't matter what, like the X is going to be 0 here because the tax is not dependent on the windows. Now my total cost is, and we have to factor that in, which is why it's at 0.50. But yeah. Okay, identify the slope and interpret the slope in the context of this situation. So the slope, if I look at my graph, I know a lot of you are going to be tempted to say 1 over 1, which is not the case because look, even though this is one box, I'm going up how much? I'm going up from 75 to 100, so I'm going up 25 over 1. And that should make sense because if we go back to the function, the number in front of x is 25, so my slope is 25. So what is my slope? 25. And what does it represent? If I want to interpret it in terms of the context, which means, when it says interpret the context, that means like for this specific problem, please don't tell me it means the rise over run because that's every slope. In this problem, the 25 is how much how much the company charges per window. How much the company charges per window. So again, most of your points are going to come from the interpretation and the explanation. More points are going to come from that than actually tell me the slope and y-intercept. I'm not saying that those aren't important. I need you to know those, but you've really got to, the whole point of math is not to be able to play with numbers, it's to be able to make sense of problems. So I'm grateful, I'm glad if you could tell me the slope is 25, but if you don't know what that 25 means, then what was the point? So yeah, so the explanations are just as important, if not more important than doing the math. So, okay. I think that is the end of this. Remember, my babies, y'all know y'all can email me questions. If you have specific questions about the practice test or about any other math, you can always email me, message me on Google Classroom. Come see me after class. Come see me during your Tiger prep period if I'm not teaching. Feel free to ask me any questions. Miss Means' kids, I'm 99.999999999% sure that she has the same policy. So, anyway, the only reason I'm saying 0.99999 is because I'm not her, so I'd hate to be like, she has the same policy. Oh, wait. But no, I'm 99.99% sure she does. So, holler at us if you have any more questions. I hope the videos were helpful. I'm hoping that we have some good scores on this unit test. Please, please, please study. Use your notes wisely. Make yourself a note card. Do whatever you need to do to make a good score. Find extra problems on your own. Hey, those of you that haven't done the homework assignments, do them now. That's a 250-point test. Y'all need the grades. Y'all need the points. I need to stop lecturing y'all and end this video. So I hope you guys had a great day. Good luck on the test, and we'll see you soon.